The night sky seems peaceful and orderly, but in reality, stars are careening through the galaxy at the speed of hundreds of thousands kilometers per hour, not bound by static formations but changing neighborhoods constantly. Fortunately, space is big, and so that the stars of Milky Way have very unlucky to hit us. Unfortunately, they don't have to hit anything to make us have a really bad time on Earth. And there are already stars starting to get very close. To understand how stars are dangerous to us, we need to talk about gravity. Gravity attacks every piece of matter to every other piece of matter in the universe. You are attracted by an atom a million light years away and vice versa. Luckily, this force gets weaker over distance, and it also depends on how massive something is. So things that are more close and very massive are more attractive, winning the cosmic tug of war. These very massive things define how smaller things behave around them. The Sun makes up 99% of all mass in the solar system, and so it shapes the behavior and orbits of everything in it. Billions of years ago, after the Sun was born, the solar system was a chaotic and dangerous place as the planets were formed from countless little pieces that collided constantly. But over the eons, a stable balance emerged. Today, most planets and asteroids have settled into safe and predictable orbits. We have the inner and outer planets, the asteroid and Kuiper belt, and at the edge the Oort cloud and a giant sphere of comets orbiting slowly in the cold storage. So we really don't want this balance to be disturbed. If another star comes close to us, its gravity would pull on everything in the solar system, like a spoiled toddler, messing up the pleasant order of the planet and asteroids and the comets. This is not something imaginary dangerous. Before 70,000 years ago, a red dwarf, brown dwarf binary system passed through a Oort cloud and messed things up. It might even have sent a deadly onslaught of asteroids on our way, but it could take 2 million years until these visitors from the Oort cloud arrive in the inner solar system. But there are much bigger problems on the horizon. Gliese 710, a red dwarf with about a half of mass of our sun, currently headed towards the solar system. At about a million years it will take pass through the Oort cloud and become the brightest stars within the sky. A close flyby like this would be unfold over the hundreds of thousands of years, disrupting the orbits of millions of objects in the Oort cloud considerably. If we are unlucky, it will trigger a new period of planetary bombardment, similar to the early days of our solar system. The night sky could be filled with comets and asteroids raining down on the solar system. The larger ones cause dinosaur-level mass extinctions, but would be bad for the stock market. But it could be much worse. The galaxy is an intense place and the stars get close to each other regularly. So it is possible that a star could come much closer, but not just pass us but fly directly through the inner solar system. This would be bad in the extreme. The chance of another star colliding with the sun is astronomically unlucky, but that is not what we are worried about. If another star were passed by about as close as the Earth is from the sun, it could easily eject the Earth from the solar system. The odds of such an event are estimated to be around 100,000 in the next 5 billion years. Small but not absurdly so. As we discussed in another video, there soon to be billions of rogue planets doing their own things in the galaxy, and this is one way to make them. So if this were happen to be with an average red dwarf, what would happen to our Earth? Kicking Earth out from the solar system? As the stars enter the solar system, a small orangish dot appears in the sky that grows bigger and brighter for months and eventually becoming visible during the day. It would get bigger and much brighter than the moon, too bright to look at directly. The night sky would be filled with an airy red glow. After a few months, it would start shrinking again. Over a few years, the sun glows smaller in the sky, and with it warmth and light start to dissipate. All around the world as the days turn dark, the final winter of humanity would be start. The polar ice caps begin to grow and separate while plants rebuild and die. Forests freeze and animals die in the droves. As the Earth passes through the orbit of Mars, the average surface temperature has plummeted to near -50 degrees Celsius. From space, Earth begins to look like an icy moon, the blue-green surface becoming pale gray-white of death. As global infrastructure breaks down, people huddle together indoors, burning what they can for warmth. As the temperature continues to drop, counting the days until they will be out of the food which no longer grows. Everybody is living at the surface is living on borrowed time. By the time Earth reaches Jupiter's orbit, surface temperature sinks to minus 150 degrees Celsius, lower than the coldest ever recorded temperature in Antarctica. Needless to say, by now, almost everybody will be die. Without the energy from the sunlight to evaporate water, clouds don't form and the water cycle will be stopped. The polar ice caps eventually touch at the equator. The oceans become covered in a thick layer of ice. As more and more of its heat leaks out, more water freezes onto the bottom of ice sheet. The concentration of salt in the deep ocean grows, poisoning most animals that survive here. Also around the hypothermal events, communities of extrophiles might adapt even to these circumstances. Deep below the ocean, some bacteria would not notice much of any of this. As the Earth reaches the orbits of Pluto and the Kuiper belt, the Sun is still the brightest star in the sky, but it is one among of many, with stars now visible during the day. The temperature is now barely 40 degrees Celsius above absolute zero, below the freezing temperature of gases in the atmosphere, a wide spectacle enjoyed by no one unfortunately, unfolds as the atmosphere turns into nitrogen and then oxygen snow. Over a few years, it is deposited into an icy 10 meters thick sheet all over the surface planet, with only a thin sphere of gas remaining. The frozen corpses of flora and fauna are buried beneath them. As the Earth leaves the solar system, it becomes a rock planet, traveling alone through a dark, lifeless and in solitude. But widely enough there is hope. But humanity would not be surprised by this potential extinction event. We did notice it thousands of years in advance. There is not a lot. We could not stop a star, but we could prepare. Most of us would perish, but a few million could survive in hug artificial examples, powered by geothermal and nuclear energy, possibly even fusion, if we can learn to use the ice around us for power. Here humanity would survive for hundreds of thousands of years, and at some points we could become used to our circumstances and new generations would watch documentaries in disbelief about the time we had our own star, and could walk the surface of Earth. And at some point we might decide to look for another home. If the Earth were lucky enough to pass by another star with a habitable planet, we could try to make a fresh star. Space flight, oddly enough, would become very easy without the atmosphere in the way. So, it's not unthinkable that the lost survivors would leave the Earth behind and try again on a new planet, around a new star. Maybe thousands of years later, the descendants of humanity will tell legends about Earth's ancient past, stories of our lost home, of a mysterious icy planet, floating alone and empty through the dark of space. So this is today's video. I will see you in the next video. Before leaving it, don't forget to subscribe our channel and like the video.